I think, okay, up and running. Let's center this a little bit. Kind of bright in here today. Alrighty, so reps are the key to making gains in this discipline. You got to be able to work with this stuff coming at you from all different directions as you move up the ladder. So let's get some reps. Graphical solution here. Even exponent. No sign change at 0. A sign change at -2, I put in the 1 for you. And a sign change at 4. Oh, let's put a dash. At 4. End behavior. I can see the first term is going to be minus x to the 4th, minus 8x to the 4th, which means that probably looking at going to negative infinity on the left side, positive negative infinity on the right. But if you put a million in, you get a positive out of the squaring, but a negative outcome because multiplication after the squaring. And then you get times a positive number times a positive number. So you're getting a negative number. So one sign change at -4, it's going to have the look of a cubic root. No sign change at 0. I forgot to put 0 here. Sign change, linear sign change at -2. That's just general idea. All right, we're looking for greater than or equal to 0. That's going to happen from -2 to 4. So probably the best way to write it, old-fashioned inequality. All right. Anything else there? I don't think so. Let's move along. We'll take the shortcut now for graphing this sinusoid. So cosine of 0 is what? Cosine is width. The hypotenuse is 1. The horizontal distance is 1, and there's no height. Okay, and so cosine of 0 is 1. So we're going to go from max to max. That's probably the easiest way to do this now. Midline, 3. Up and down, 8 units. 11. Down 8 units, -5. So our range, y values from -5 to 11. Pi x over 4, what does it stand for? Hope you said an angle. And what way are we going to express our angles? Radius lengths. So our first radius length is 0. I haven't started walking around the circumference. So when does pi x over 4 equal 0? When x is 0. We're at 11. What am I multiplying x by? Really by pi over 4. And if we divide that into 2 pi, we're going to get our period. 8 pi divided by pi is 8 units, right? 2 pi times 4 over pi. Pi's cancel, we get 8 units. So over here at 8, I'm going to get 11. Let's set this to 2 pi. So pi x equals 8 pi. X is 8. So the period is 8 units from max to max. Could have written it with different angles, but those seem to be rather salient. Graphing one period for the sine function. Well, at this stage, I think we're hearing it enough that the sine of 0 is 0. Sine measures height, so the midline is 0. Pi over 2 is 1. 3 pi over 2, -1. So we want x minus 2/5 to equal 0. And I'm multiplying x by 1/5. If I divide that into 2 pi, I get 10 pi. So we're going to go from 0, 0.77, back to, what did I say, 10 pi. 77. I'm just showing you the shortcut. What I'm really doing is I'm solving this for, oh, it's not 0, I wanted a 2, right? I always do something stupid, which means that this is 2 plus 10 pi. Not going to do the video again. These things happen. Right, so that's the period, though. That's the length of input. required to get back to the midline. And we're gonna go up to a height of 80, right? 77 plus 3. And our smallest value is gonna be what, 74? So our range is 74 to 80. Woo. Three Stooges, yep, up and down. What else is there? Well, we got all kinds of 2 plus 5 pi. It's gonna get us midline. 2 plus 5 pi over 2. I said that quickly. I'm just dividing this by 2. It's gonna get us 80. Then I suggest you put 2 plus 5 pi over 2 in here. 2 plus 5 pi over 2. And we can see the 2's cancel. And we can see that division by 5 is multiplication by a fifth. And that gives us 5 pi over 10, which can be reduced to pi over 2. And pi over 2 gets us a maximum of 1 times 3 plus 77 gets you 80. So all kinds of symmetric points once you get the start of the period and the ending of the period. All right, there's our reps for that. Okay, what do we got to be worried about for domain? We got to be worried about division by 0. Can't do that. We got a log. The parentheses have to be greater than 0. We got a square root. Square roots have to be 0 to positive, so they cannot be negative. So we got a lot of issues here. So let's get a number line going. Well, first off, numbers have to be bigger than -2. Oh, but you know what? I don't even have to look at that because this has got to be bigger than 0. So I'm going to cut right to the chase. That's got to be bigger than 0. Why did I write 2? So we don't even have to worry about the numerator here because numbers have to be bigger than 0. All right. They also, parentheses, right? I can't divide by 0 and 1 over log 0. I don't care what the base is. That's undefined. Well, sorry. I already did that one. Log 1 is a problem. Why? Well, this is actually a common log because 10 to the what equals 1. Well, that's a 0 and I can't have a 0. So it looks like I can't use the number 1. So there's my 0 to 1 union 1 to infinity interval notation. That's your domain. Moving right along. Let's graph a rational function. Day 4, I hope, is a magical day. If you've been doing the series each day, just 20 minutes, 30 minutes, then you can get down to probably 5 minutes doing all these 11 problems, but we'll see. So we got critical numbers at -2/5. That's, why did I pick that? Should I change it? Yeah, let's just change it real quick. Critical number at -4. That opens up the graph a little bit. Let's put the denominator in the factor 4. Well, let's get our y-intercept first. 20 over -6, 10 over -3. So -3 1/3. That'd be about there, I think. 0, comma, -10/3. Y-intercept, -4 is 0. X-intercept, asymptotes at x squared minus x minus 6 is x minus 3 times x plus 2. But remember, we have x to the 1 in the numerator, x to the 2 in the denominator. That is eventually going to go in towards 0 as I put bigger and bigger positive and negative numbers in. So we got some asymptotic behavior. Yeah, the graph centered pretty well. So we've got an asymptotic -2, undefined situation here, and one at +3. That's about here, I think. So there's no symmetry here in the center, and we don't have any other x-intercept than this one. So therefore, we have to find out if we're above or below to see what the behavior is there. And what else? Putting positive numbers in gets me big positive, gets me a positive over a positive times a positive, which is a positive. So therefore, we can see that. Also, this is to the first power. They're all to the first power, which means we're going to get sign changes. So therefore, we're going to get a sign change here, which means that this has to either bend back down? It can't. No, it's gotta bend back down. So I don't know where the local max is here. I don't want to mislead. It's probably closer, it's probably more on this side. But I'm not sure. It's probably going up a little bit there. We'd need to get a calculator or some calculus to figure that out. So we'll leave that be at the moment. Then I'm gonna get a sign change at -2. So I know that it actually has to do this, come back to 0. And I suggest let's put -5 in just to show that we get a little negative. Okay, and then we'll put -3 in maybe to show that we get a positive result. All right, so -5 gets me -5 over -8 times -3 is 24. So that's gonna give me small negative. And -3, if I put -3 in, I get a +5. -6 times -1 is +6. So I hope you can see that at -3, we are getting a positive result. When am I less than 0? Well, from -infinity to -4, I'm answering this question, from -infinity to -4. And that can't be bounded. And negative, I said, right? And from -2 to x, I didn't label that. From -2 to 3 is when this graph is negative. -2 to 3. I think that says it all. Domain. Domain is okay. We can talk about domain. Range would be difficult because we'd have to do more analysis here. So domain, -infinity to -2, -2 to 3, 3 to infinity. All right, and there aren't any points of discontinuity. So let's go do the next one. I can immediately see a 3-to-1 ratio. 3x over x are the big players when we put big numbers in, and that goes to 3. Oops. There. All right, so we're going to go to I to 3 on the right and the left. Asymptote at 4. Y-intercept of -2.25 or -9/4. So we'll call that about there. That's 0, -9/4. No points of discontinuity. Pretty straightforward. So it looks like we're going to have one x-intercept at -3. And so -3 gets you to 0 in that fraction. And so we can start to see the trajectory here and the trajectory here. So I'll just add a question here. What's the limit as x's go towards 4 of this function g of x? We'll give that some thought. I'll just keep going. The answer to that doesn't exist because I'm not sure if I work towards 4 from the left, -1, 0, 1, 2, 3, 3.5, 3.9, 3.99999. I'm heading to -infinity, and then I get a sign change, and I head to +infinity when I put a number like 4.01 in there. Okay, hopefully you can see that. Oh, what if I wanted to say going to 4 from the left? Yeah, that limit exists. I'm going to -infinity. If I'm going to go to 4 to the right, +infinity. But if I'm just talking about 4, I'm not going to the same y values. Can't make a statement. Okay, hopefully that was enough practice on that one. V shape up. I'm going down at 12-to-1 on the left, up at 12-to-1 on the right. I'm going to use -1 as my x value, which produces no distance, which is a minimum, and that gives me -7. I'm going to use the slopes here. Instead of writing this 3 parentheses 4x plus 4, I'm going to Alfred Hitchcock it with a -12 through the point, -1, -7. We're pretty good at that. But that only happens for x values less than -1. When my x values are greater than or equal to -1, I'm on the upslope. 12x plus 1 minus 7. Let's get one more value in here. Let's get the y-intercept so we can see the up 12-to-1 ratio. Put a 0 in, you're at -19. Ooh. Oh, I've got the wrong one. I gotta put it in here. That's why. Pointed to the wrong one. On the upslope, we're using this function, put a 1 in, 24 minus 7, 17. Yeah, that's better. And how do you get from -7 to 17? I go up 24 units. Did I make a mistake? Yes, I did. 24 minus 7, 17. 3 times 4 is 12. I should be at 12-to-1. I put a 0 in. Oh, that's what I did wrong. Excuse it. I made my boo-boo. Put a 0 in. 12 minus 7 is 5. How do you get from -7 to 5? You go up 12. -1 to 0, go up 1. We can see the 12-to-1 ratio of change. So I hope you can see the interplay of those two multipliers. All right, so now let's find out when we're equal to, I don't know, what do we want to say? How about if we go up another 12, we should get an answer of 1 gets us 17, because I already found that one, right? Yeah, and over here, -2 gets us 5, so a -3 should get us a height of 17. So let's solve this for 17, because I think we know our answers. -3 plus 1 divided by 2 confirms that the symmetry exists. And I'm doing all this off screen. Okay, tired today. So -12, x plus 1 minus 7 equals 17. There's our 24, there's our there's our positive 12. There's divided by -12 into this -2. Woo! Subtracting 1, there's our -3, which we said it would be. Positive 12, x plus 1 minus 7 equals 17. There's our 24, there's our positive 2. Take away 1, there's our 1, which we said would be the case on the graph. 1 would get us 17, -3 would get us 17. What am I bigger than this? What am I bigger than 17? Well, if you put your answers there and put a 1 and a -3, you're going to find true, false, true, which I hope can make you dizzy, which I hope you can see is those are the Y values, right? Can you see the kind of the number line, the true, false, true? Hope you can. All right, 2 ways to do this sinusoid. What does X stand for? Hope you say angle. So we got to turn years into angles before we get those values. So what's 1900 going to get us? Well, it depends on whether we're using a sine or a cosine function. If we're using a cosine function, you got to be careful here, because 0 is the midline of sinusoids. And we're at a midpoint with widths increasing. And if I go to pi over 2, there is no width. But the next triangle, the width becomes negative. And negatives are going down, not up. So I really have to attach this to 3 pi over 2. Because that's where my width is 0, going up. But you don't have to do a cosine curve if you understand that one period of the sine curve looks like that. That's what we have. Okay, I'll highlight that and highlight it here. Hopefully you can see how similar that pattern is to this one. So let's do height. Height is sine function, and we're at the middle going up at 0. And then we'll come around to 2 pi and we'll get, well, that's different graphing. So here we have to have 1 pi, 2 pi, 3 pi, 4.5 pi, which is 9/2 pi. 9/2 pi, and that took how long? 23 years. So dividing by 23 over 1 is the same as 1 times 23. So 9 pi over 46 is what we're going to get. But I'm going to express it as 4.5 pi divided by 23 so that you can see the mechanics of this. All right, so let's just get the job done here. I have to put some numbers in. I did, mid-range is 50, so I didn't draw this, but that's 50. All right, and that's where we're gonna start. We're gonna do the sine function. How do I get to 75? The amplitude's 15. I've got the sine function, and I've got 1 pi, 2 pi, 4.5 pi. And that took 23 years. No, 123. Boy, I am in a fog. 123 years, x minus 1900, and that can end in 0. So that's the most succinct way perhaps to do it. I think if I've analyzed this correctly, I didn't expect to have this discussion here. But I believe these are the same. 4.5 pi over 123. 123 x minus 1900 plus 3 pi over 2. All right, so what do we get when we put 1900 cosine of 3 pi over 2? What's the cosine of 3 pi over 2? 0. And then plus 50 gets us 50, so it nails that. And then let's put, what would be easy to put in here? I guess 2023, because we've got to do it. So 2023, 123 cancels, 4.5 pi. So here's 1 pi, here's 2 pi, 3, 4.5 puts me here. What's the width? The width is 0. And so, yeah, brings me back to 50. All right, looks good. Might have to do the video again. I don't know. If I make any more mistakes, I will. Let's get this out of the way. Yeah, I need more sleep, that's for sure. We'll do rule of logs first. Ln of 3/10 is going to become the ln of 3 minus the ln of 10. So this is going to be the ln of 3 minus parentheses or brackets or something, because the ln of 10 is the ln of 2 plus the ln of 5. We got ourselves an algebra 1 distributive property that we need to take care of. And so now I can change to numbers. 1.1 minus 0.7 plus 1.6 gets 1.1. No shortcuts here the way I'm computing today. 2.3. So what's that? Negative 1.2. Negative 1.2. Okay. Let's see if that matches up over here. And if it doesn't, then I gotta start all over again and try to wake up. All right, so 3/10 in E notation is e to the 1.1 approximately, so I'm gonna have to say approximately. 2 is e to the 0.7, and 5 e to the 1.6, and I hope you can see that we have e to the 1.1 minus parentheses 0.7 plus 1.6, which is expressed over here. 1.1, this is ln is all about exponential activity. Here's the exponential activity, which is 1.1 minus 2.3, which is the opposite of 2.3 minus 1.1. Just coming at this answer a little bit differently to make sure I didn't make another careless error. All right, so that's that. How do you get good and quick at doing logs, graphing logs? Understanding the mantra, set the parentheses to 0, set it to 1, and set it to the base. Oh, I'm doing ln. All right, ln is a special log. I like to use ln of 3, ln of 0, and ln of 1. You have to understand ln of 0. Log 0 of any base is undefined. There's no way that you can make something equal 0 when you're doing this exponential problem. Negatives get you small fractions, positive get you big amounts, and e to the 0 is 1. That basically covers it. E to the negative x is 1 over e to the x, that's positive. E to the 0 is 1, and e to the x is always positive. It's always positive, right? Y equals 0, it's above that. So you're not going to be able to go backwards and find something that gets you 0. All right, so let me just bang this on the board very quickly. All right, so we got undefined at 5. X equals 5. We need numbers bigger than 5. Let's throw these in. I like a 1-to-3 ratio. That's why I pick the number 1. So 6 gets me, where am I? 6 gets me 7. And I'll go to 8, which makes this 1, which makes this 3. Okay, and that makes this thing 0. Right? So 8 gets me this 8 gets me the element of 3, which is 1.1. 2.2 plus 7, 9.2. It's gotten a little muscle memory from the logarithms we've done from day 1, day 2, and day 3. Okay, but I wanted to switch gears just a little bit. Let's locate, how about x equals 5 and 1/25? Let's make it 1/125. All right, so what is 5 and 1/125 minus 5? 1/125. 1/125. What is 125? It's 5 to the 3. What is 5? E to the 1, e to the 1.6. So 3 times that is 4.8, and it's negative. And if I double that, it's negative 9.6 plus 7, which is negative 2.6, which is way down here. Okay, so hopefully you can see I'm getting closer to 5. Trying to get a deeper understanding as we go through the second half of the term. Right? And an understanding of calculations requires some number sets. So you got to be able to manipulate some numbers, and that's going to take some practice. Cosine of 11 pi over 3. Should do it in your head. 12 pi over 3. So 11 pi over 3 is 1 less. This should be a half. All right, let's see if I made a mistake. So there's a circle. Not bad. A little off center, a little rotator cuff. All right, so we got 3 good drawings, get good answers. So there's 6 altogether. 6 chunks of 3. 12 chunks of 3 brings you back again. Right there. And I'm looking at 11, which is 1 less, which is right here. But cosine is width, and that width is positive. And yes, it is a half. All right. Whew, out of breath. All right, I think I'll upload this, even though I had a little stumble in the middle. Corrected it, and that's part of the learning process as well. All right, see you in class in another week.